All right, let's look at derivatives in Desmos. I want to take this video and explain a little more about derivatives from a graphical perspective. So first of all, we've got a function here. F of x is x cubed minus 3x. And if you actually type it into Desmos like this, defining it by name, giving it the name f, or you can use p or h, you can use the apostrophe character to graph f prime. So it doesn't actually tell you an algebraic expression for what f prime is, but it does show you the graph. So now we have the red curve here, which is f, and the green curve here, which is showing us the graph of f prime. I'll hide that just for a moment, and we're going to look at the relationship between them. But first, I want to show you how you can graph a tangent line. So the equation of a tangent line is in the y minus y, like y0, right, equals m times x minus x0, right? So that's the format, but using the function, the x0, let's have that be, let's c, okay? And then y0, the y coordinate of that point would be f of c. There we go. And then the slope m, that's going to be the derivative of the function f evaluated at c. So we replace the m with f prime of c. So now the only unknown in this thing here, the only variable here, well, we got the x and the y, sorry, but the only like parameter involved is c. So we can add a slider for c. And now if I drag this around, let me adjust the boundaries here. Let's have that be -5, 5, so it moves a little smoothly. Now, as I adjust this around, you can see the graph of the tangent line smoothly sliding around the function, which is kind of nice, fun to watch. Just kind of helps to wrap your head around like what a tangent line really is. Also plot the point of tangent at c comma f of c, so we can see that spot too. Yeah, there's the point on the graph, and we see the tangent line moving around. Okay, so now let's look at the function f and the function f prime. F prime is here in green. Red and green might not be the best colors to use here, so let's go ahead and change this to red, blue, red and blue. Sure. So blue is the derivative, and red is the original function. And one of the first things I want to point out is that there are some points where the tangent line is pretty much horizontal. One, I think. There we go. Yeah, so at x equals 1 over here, our tangent line actually is horizontal. And the reason is because the f function is hitting like a low point right there, right? That's the local minimum. So at that point, when we have a horizontal tangent line, that slope is 0, and so we see the graph of f prime crossing right through the x-axis right there. So that's going to happen twice. Let's see. It happens as well also right over here at -1. And there we have the 0 slope, and then we've got the derivative passing through 0. So there's that. The next piece of information we can point out is when the derivative is positive versus negative. So if you think about moving from left to right in this direction over here, like this, when the function is increasing as you move from left to right, the slope of the tangent line is going to be a positive number. So like right now, the tangent line is increasing a positive slope. But once you pass over that local maximum up there, now the function is decreasing, and the tangent line has a negative slope. Those things are corresponding to each other. So decreasing, and then it passes the local minimum, and now it's increasing. So if you look at the graph of f, this is corresponding to where the function, if you look at the graph of f prime, this corresponds to where f prime is positive, negative, and then positive again. So we see when f is increasing, f prime is positive, and when f is decreasing, in between -1 and 1, f prime is negative. Okay, the last thing I want to do is change f a little bit. So let's throw a plus constant. I'm going to put the letter a. So let's say a is just a constant, an arbitrary constant. We're adding it at the end of f of x. So what that is going to do is take our function f and shift it up and down. You may remember vertical shifting from the unit on transformations of functions back in pre-calculus or college algebra. Here I'm shifting it up and down, but as you can see, that does not have any impact on the derivative of f. So f prime here is being recalculated dynamically as I change f, but it's staying the same. This is different from, for instance, if I had like multiplied by a, that's going to have a significant impact on my derivative. You can see the derivative is changing as I change the original function. But if you just add, shift it up and down, that doesn't change the derivative. So this is useful information. The reason, of course, is because when you shift something up and down, you don't change how steep the tangent lines are. All you're doing is moving them up and down, right? That's not changing their slope. And so that's why it doesn't have an impact on the derivative. We're going to see more of an analytical perspective why this happens in a minute. So that's the stuff I wanted to show you on Desmos. Come over here. My next tab over here is this GeoGebra. This site. This is from Shippensburg University. This was some GeoGebra applets created by Mark Renault. I really love these. There's some really cool stuff in here. Derivatives of this is one that's about derivatives of elementary functions. Here you can see we have a parabola. This is x squared. You can kind of drag the x value along, and you can check this box to show the tangent line. There it is. And you could plot the point which would occur on the graph of the derivative, which would be this c f prime. You can see that moving around, and that's kind of cool. You can see where it would be. So you see when we have this tangent line of slope 0, that red dot is on 0, 0, right? That's at height 0. Here we have positive slopes, so the red dot is above the x-axis. Here we have negative slopes, so the red dot is beneath the x-axis. And if you have it trace out the shape or the graphs being sort of traced out by that red point, we see that's the graph of f prime. That's the graph of the derivative there. And we see it's a straight line in this case. So I'm going to show you in the next video, I'm going to show you a couple other things you can do, a couple other applets that are on this website, and I will post a link to this website in detail for you to go and play with it on your own. But that'll about do it for this demo. I'll see you in the next one.